Good morning, everyone. Today in this session, I'm going to discuss about the implementation of SVM algorithm, that is support vector machine. Hope you remember the logic behind what is this support vector machine. It is a classification algorithm, and we are going to use a hyperplane, and the distance between the how much large the margin is, that much accurate the results will be. That is what the support vector machine. So here, for this implementation of this SVM, I have used a dataset called breast cancer dataset. And here you can see the link of this dataset, which it is from UCI ML datasets. So this is the link here. From here, you can download the original dataset of this breast cancer, and I have uploaded it into my drive. Now, the next step is we are going to import the libraries. We know that NumPy, Matplotlib, and Pandas. And then I'm going to import the dataset into our file. That is with the help of a function called as pd.read_csv. This pd is from Pandas. And I'm read_csv. Just I'm giving the dataset file. That is breast cancer Wisconsin in.data.csv. This is the file name. Just I'm importing into my file. Now, next, this I'm printing the shape of the data set. That is, it is of 698 rows and 11 columns. And here I'm printing the head of this data set. That is the first 5 rows. These are the first 5 rows of the particular data set. And then the next one is I'm splitting the data set into X and Y. For that is extraction of independent and dependent variable. For that, I'm using the ilog function. And this 8,9, here I'm taking only the last two independent variables, 8 and 9. And the last 10th one is the class label. Here they have given 2 and 4. That is, 2 is who is not having the cancer, and 4 belongs to the person who is having cancer. Like that, they have defined here these 2 class labels for this particular data set. And here I want to discuss this data set also. Okay, I'll discuss. Now, next, I am printing this X variable, and I'm printing this Y. And the next one is, we know that we are going to split this data set into training and testing. For that, from sklearn.model_selection, we are going to import train_test_split. And we create 4 variables: train, test, train, xtrain, xtest, ytrain, ytest. And y and test size of 30% of testing, and random state equal to 0. And next, when I saw the data set, I found that there's some normalization of data is required. For that, I am using one pre-processing step. And from that, to the scalar.preprocessing, I have imported the standard scalar. And for training, we know that we have to fit and transform the training data. And for testing, we can directly transform the test data. Now it's time to build the model, that is the SVM. For that, from sklearn.svm, we are going to import SVC. Okay, so from SVM, we are going to SVC, and that for that classifier, this SVC, we require 2 attributes, that is kernel and random state. And even the theory part, we discussed about these kernels, where if we have a non-linear data, it is going to convert it into a linear data by making one-dimensional to two-dimensional, or when the data is in 2-dimensional, it is going to convert it into a 3rd-dimensional. And we have this many different types of kernels, like linear, poly, sigmoid. But here I am taking the RBF kernel, that is radial basis function, as the kernel for this support vector machine. And then I am fitting the training data of xtrain and ytrain for this SVM model. And then I'm predicting the results. For that, we use the classifier.predict, where we have given classifier as this one. So I'm with the predict function, I'm predicting the test data. And next, we know that we have to evaluate the classification algorithm. For that, from sklearn.matrix, I'm importing this confusion matrix and accuracy score. And I'm printing confusion matrix of test data and predicted data. And for accuracy score, the same test data, predicted data. So this is the confusion matrix, where I have true positive, true negative, false positive, false negative. In the accuracy, for this particular data set using SVM, I got some 90% of accuracy. And then, like earlier, I have created a data frame which I want to show the actual and predicted. So here you can see Here the actual is 4. That means that particular person is having a breast cancer, but it predicted no cancer. Here, no cancer, even predicted also no cancer. Here, cancer is there, cancer is there. Like that, what is actual and predicted? So that from here, we can easily find out how many false positive and false negative our model has done. And now, from now, the next one is to print the classification report. So here from sklearn.metrics, I'm just importing the classification report and printing classification report for again test data and the predicted data. So this is the precision for 2, that is no cancer, and 4 which having the cancer. So this is the results of precision, recall, and F1 score. And total we got 90% accuracy. Now, this is just you need not to remember or you need not to uh, execute this piece of code. This is a piece of code. You have to remember, you have to maintain one sheet to copy and paste this. What is this here is, I hope you remember the SVM classifier, how it looks like when we discussed in theory part. The same here. Here, this is how the SVM classifier shows the result. So see here, this is the image. Where we are printing, these are the data set, these are the results. So here you can see this blue says a particular person is having cancer and the red says there is no cancer. So this particular, in blue when you see red and in red when you see blue, this shows the misclassification, how many misclassification our model has given. So for visualizing such data, even though we already found here that what is the actual value and predicted value, but to visualize that, what are the misclassification our model has done, especially this SVM has done. But to print this, we require this piece of code, that is mesh grid. Generally, we call it as mesh grid. Okay. From that mesh grid, see here you can see we have a Y label class as 2 for benign and 4 for malignant. Malignant means he is having cancer. 2 for benign means he don't have any cancer. And labels equal to no and yes. The same thing I have written here. You can see class, and this is mitosis means one of the feature I have taken from the given data set. So one feature I have taken, that is independent X feature I have taken here and Y feature I have taken. And in blue, when you see red, it is a misclassification. And within the red, when you see the blue, this is a misclassification. So this is how an SVM algorithm works. Thank you.